In this session, we look at learning curves. Learning curves, the idea is very simple. That is when we do something again, again, the time we need to perform such a task will decrease. Basically, it means we learn from repetition. The more we do the same thing again, again, then the shorter the time we need. Analytically, we can look at this learning effect this way. We have a horizontal axis, which is number of repetitions. So it goes from 0 to the right hand, which is a number of repetition increases. The vertical axis is the time we need to finish the job. So start from 0 to a higher number. For example, at the beginning we have a low number of repetitions. We just start to learn. Then the time we need to finish is quite high if we look at the vertical axis. Now, the more we repeat the same task, the number of the repetition increases. And then the time we need to finish, look at the horizontal line, time we need to finish the job decreases. There are a list of factors that will contribute to learning effect. For example, the learning. Okay, and also the preparation. For example, tooling and effort we used to set up the job. Okay, set up in a way it's easy to finish the task. And then we can also do method analysis. Method analysis means we can basically set it back and look at the overall how we perform the task and do a little analysis and try to improve that. Also, we can change the tooling and equipment, the planning, scheduling, also the motivation and the control when we talking about the managerial factors. We also know that motivated workers and less motivated workers finish job in a different speed. Okay, we know that we can improve our learning effects. In other words, performing the task faster when we introduce some new tools, new method. Okay, so for example, here this is the old tool, old methods. We perform the task many times. The time we need to finish the job goes down. When we introduce a new tool and a new method, we need to learn how to use it. We need to get used to it. Okay, we need to learn how to use those new tools. And then we have to spend a little bit more time. So at the beginning, at the moment that when we have a new tool, a new method, the time to finish the task jumps a little bit. And then after we get used to it, it goes down again. And then we have some other new tools, new technology to come out, a new method come out. Then the time to finish the job jump a little bit again, and then we learn more about it. It goes down. Other than just understand the idea of learning curve, the learning effect in terms of percentage is predictable. So here is a way we can calculate, we can predict the hours we need to finish a task in the future. For example, we have a task. The first time we finish it, it takes 100 hours, and we know the learning rate is 90%. What do? Is we set up a table. The first time we run this, it takes 100 hours right here. Now the second time, it will take 90% learning rate times the hours we finished it in the first run, which is 100 hours, so it becomes 90 hours. The fourth time we do it is 90% times 90 hours, which is here. 90% times 90 hours equals to 81. And the eighth time is again 90% times 81 from here, so it equals to 72.9. Now we can also calculate 16, the number 16, the number 32. Well, here you're probably going to have a question. Where's number 3? Where's the third run? Where's the 5th, 6th, 7th run? What happens is the learning rate applies this way. It goes this way: 1, 2, 4, 8. If we want to use the formula here, if we need to calculate the third run, the 5th, 6th, the 7th, and etc., which is missing in this column here, here's the way to do it. The nth time, okay, T means the time we need to finish the job. The footnote N here gives us the nth time, the nth unit, equals to T1. What is T1? That is the time for the first unit. Tn is the time for the nth unit. Tn equals to T1 times n to the power of b. N is the nth unit. B equals to ln the natural log r divided by natural log 2. For example, if the learning rate is 90% and the first unit took 100 hours, how long will it take to complete the 25th unit? So the calculation goes this way. The T25, which is the time we need to finish the 25th unit, equals to 100 hours, which is T1, times 25th unit to the power of ln 0.9 divided by ln 2 from our formula, from our last formula. Finish this calculation here, okay, we get 61.3 hours. That is the time we need to finish this 25th job. What makes managerial sense is that at the beginning, if we know at the first time when we finish these unit, if we know the learning rate is 90%, then we can predict the time we need to use to finish the 25th unit. 26, 27, we can do all of them as long as we plug in numbers here in this formula. For field use, a lot of times we prefer to have a table to calculate this learning rates. So we're going to have a way, I'm going to show you a way to calculate the learning rates without using this calculator. Now here's an example. If the learning rate is 90%, the first unit took 100 hours to complete. How long would it take to complete the 25th unit? So this is the same example we have just done. Now we're not going to use the calculator. We're going to use a table. So here's the table. We know the unit number we need to finish is the 25th. So in the first column, the unit number, we look for 25th. And then we look for the learning rate, which is 90% in our case. So on the top row, we look for 90%. And then what do we need to find is the 25th unit, right? So we look in this column, unit time. Okay. So unit time in this column, when the unit number equals to 25, then the factor here we're going to use as 0.613. Remember this number because we're going to use it right away. 0.613. how we find the time we need to complete the 25th unit. T25, which is the time we need to use to finish the 25th unit, equals to 100, which is the hours we need to complete the first unit, times a simple number we found from the table, 0.613. That will be 61.3 hours. That is an easy way. We use the table, and we do not need to use the calculator. Second question. Now, if the learning rate is 90%, the first unit it took 100 hours to complete, so it's the same thing. How long would it take to complete the first 25th unit? The first 25th unit means how the time we need to finish from the first one until the 25th one. So all the time we need from 1, 2, 3 all the way to 25th. How do we do this? Again, we're going to use a table. We find 25th unit in the first column. Learning rate, again, 90%. Now we look for the total time instead of the unit time. And total time here means, in our cases, from unit number 1 to unit number 25th. All the units here from 1 to 25th. So all these units here. Then we find a number that is 17.713. We're going to use this number. Now, since we found that from the table, the factor we need to use is 17.713. Now, how long would it take to finish the job from the first one until the 25th unit? Here's the calculation. It will be the time we need to finish the first work, which is 100 hours, times the number we found from the table. That is 17.713. It equals to 1771.3 hours. That is the total hours we need to finish for the whole first 25th units, from the first one until the 25th one. So this one saves us quite some time, because now it gives us a single number right away. We do not need to use the calculator 25 times. This learning curve calculation, this tool, can be used at a lot of places. For example, the manpower planning, the scheduling, and the negotiated purchasing, and pricing, and etc. What is interesting here is that, for example, when we contract a job to a contractor, okay, we give a job to the contractor, they will charge us, they will negotiate with us a certain amount of the charge. And then they will charge us based on hours. So where does this hour come from? Okay, if they give us an hour, do we believe it or not? Now that's the interesting part. We can find out the learning rate, find out the time they need to do to finish the first job. A lot of time they have done this before. And then we can use this tool to predict and have a estimation on our side instead of just simply believe the contractor's quote. And if we need to negotiate with them, we need some base on our side. Basically, we need to have a prediction with numbers, with rigorous analysis as something we need to prepare before we get into the negotiation.